we want to show that a sub n equals 6 times 2 to the power of n plus 9 times 3 to the power of n is a solution to the recurrence relation a sub n equals 5 times a sub n minus 1 minus 6 times a sub n minus 2. To do this, we'll first have to determine a sub n minus 1 and a sub n minus 2 using the closed formula. Then we'll perform a substitution into the recurrence relation and hopefully show that a sub n equals 6 times 2 to the power of n plus 9 times 3 to the power of n. To begin, to determine a sub n minus 1, we substitute n minus 1 for n into the closed formula. And to determine a sub n minus 2, we substitute n minus 2 for n, again into the closed formula. And now using the recurrence relation, a sub n equals 5 times a sub n minus 1 minus 6 times a sub n minus 2. We have 5 times the sum of 6 times 2 to the power of n minus 1 and 9 times 3 to the power of n minus 1, and then minus 6 times the sum of 6 times 2 to the power of n minus 2 and 9 times 3 to the power of n minus 2. From here, we'll clear the parentheses by distributing. Distributing 5 gives us 30 times 2 to the power of n minus 1 plus 45 times 3 to the power of n minus 1. And then we have minus 36 2 to the power of n minus 2 minus 54 times 3 to the power of n minus 2. Remember, our goal here is to show that a sub n is equal to 6 times 2 to the power of n plus 9 times 3 to the power of n. So we need to work on making the exponents on the bases of 2 and 3 equal to n, not n minus 1 or n minus 2. And we can do this pretty easily because 30 has a factor of 2, 45 has a factor of 3, 36 has 2 factors of 2, and 54 has 2 factors of 3. So for the next step, we write 30 as 15 times 2, 45 as 15 times 3, 36 as 9 times 2 times 2, and 54 as 6 times 3 times 3. Now the reason we're doing this, if we multiply 2 to the first and 2 to the power of n minus 1, this will give us 2 to the n, and therefore 15 times 2 times 2 to the power of n minus 1 is just 15 times 2 to the power of n. And then 15 times 3 times 3 to the power of n minus 1 gives us plus 15 times 3 to the power of n. And then we have minus 9 times 2 times 2 times 2 to the power of n minus 2 gives us 9 times 2 to the power of n, because 2 to the first times 2 to the first times 2 to the power of n minus 2 is just 2 to the n. Similarly, for the last term, we have minus 6 times 3 times 3 times 3 to the power of n minus 2, which just gives us minus 6 times 3 to the power of n. And then the last step is to combine like terms. Notice how we have 2 terms with a factor of 2 to the power of n, and we have 2 terms with a factor of 3 to the power of n. 15 times 2 to the power of n minus 9 times 2 to the power of n is 6 times 2 to the power of n, and 15 times 3 to the power of n minus 6 times 3 to the power of n gives us plus 9 times 3 to the power of n, which is our formula for a sub n. So this does show the closed formula is a solution to the recurrence relation. And then for the second part, what would the initial conditions need to be for this to be a closed formula for the sequence? In order for the recursive definition and the closed formula to give the same sequence, a sub 0 and a sub 1 must be the same, which means we now need to determine a sub 0 and a sub 1 using the closed formula. Again, the closed formula is a sub n equals 6 times 2 to the power of n plus 9 times 3 to the power of n. To find a sub 0, we substitute 0 for n. A sub 0 is 15. And to find a sub 1, we substitute 1 for n. A sub 1 is equal to 39. These would need to be the initial conditions. I hope you found this helpful.